All right, I'm back. I'm on page 236, and I'm going to do this problem. So let R be the region in the first quadrant bounded. I don't know if you can hear that. Like my thumb clicks often at the beginning of these videos. There you go. I don't know if the mic is picking that up or not. Let R be the region in the first quadrant bounded by the coordinate axes and the function f of x equals negative 2x plus 4. Sketch the region, find its area, including units. All right, we got this. So first quadrant region, I would say first quadrant regions are like very common. And then I'm just gonna go like, oh, don't go up there. Maybe this. All right, so this is gonna be y equals negative 2x plus 4. So this would be 4. And then when x is equal to 2, you get 0. So I think I haven't screwed this up yet. What I'm going to do is just kind of, fill it in, shade the region, right? Because you want people to be able to see the region. You want to be able to see the region, know what you're talking about. This is definitely a triangle. And, we could write equations that will like fill this in, just like inequalities, like x goes from 0 to 2, y goes from 0 to negative 2x plus 4. Let's not, but we could. So triangle, base of 2, a height of 4. I swear that what we're doing now is excellent preparation for calculus. It doesn't feel like it because this feels very like middle schoolish almost, except for like the function. But it's a big deal because you got to be able to like take functions, find regions, find areas of regions. It gets a little more complicated, but like not much. It's certainly not much if you understand how this is working. 2 times 4, 1/2 base times height. So 4 units squared. All right, let's move on to the next part. So take the region R and rotate it about the y-axis. Describe the solid formed as completely as possible. Find the volume of the solid, including units. All right, so this is where the fact that we took forever on the last problem is going to kind of pay off a little bit, because this one's a little different. But so I'm going to start again just with the picture, something like that. And so like it's important to have the markings so that you like know what's happening, right? So this was x and y. And so we're going to turn this into a 3D-ish thing. I'm going to try to do that. So it's a triangle. And when you rotate a triangle, you get a cone. So I know that I'm going to get a cone. I know I can describe that cone right now because we're going around the y-axis, but I'm going to do that later. Why do now what I could do later? All right, let's label this. So that's x, that's y, and that is z. And so what I want to do is I want to take these markings and translate them over to this. So I'm going to start off on the y-axis and just do a tick mark parallel to the x-axis and say that that's at 4. And then on the x-axis, I'm going to make a tick mark parallel to the y-axis at here, and I'll say that this is 2. And then what I can do is just connect those. And so that's our region taken from the XY plane into like space. We didn't rotate it yet, but that'll be in space. So we're going around Y. So let's draw a little thing here to show that that's what we're going around. It should really like be on the axis, but I put the Y in a weird place. You know what I can probably do? Through the magic of whatever I'm doing, I can just move these around. All right, so let's do that. All right, so as we rotate around the y-axis, eventually our figure is going to get into the YZ plane. And when it gets into the YZ plane, it's still a triangle. The distance from the origin out to like the tip along the Z axis is still going to be 2 units. So I'm going to put a tick mark and say that it's 2. And then I will draw from this tick mark down to here. And so that's our original region in the XY plane rotated into the YZ plane. And then we can fill in this to kind of like show the cone. So we're only drawing a quarter of it, partly because I am not talented enough to do more than that. Partly because that's all you need. Remember, way back at the beginning of these, we talked about the first octant being like the most important. That's where you typically draw your things. So we have this. All right, so I'm gonna do the easier of the tasks, right? I'm gonna get a cone. So it's gonna be a cone, and it's gonna have a radius of 2 and a height of 4. And so the volume of a cone is 1/3 pi r squared h, which is useful to know. So the volume in this case is 1/3, the radius squared is 4, times 4 is 16. So I'm gonna say it's 16 pi over 3, and then our units will just be units cubed. Okay, so now what I wanna do is I wanna work out what's happening. All right, and the way we're gonna do this is really similar to what we've been doing. I'm going around the y-axis, so y is gonna be its own parameter, and I already know that for this picture, this will be true. I'm gonna make y its own parameter, maybe like v, or yeah, probably v, and I'll say v is between 0 and 4. All right, now let's get into it. Let me set this up a little bit. Okay, when you're in the xz plane, you get a circle that definitely has a radius of 2. But we want to be able to move. So like that's when y is equal to 0. When y is equal to 1, for example, so when y is equal to 1, I get something else, right? The radius is something different. But the radius is actually just whatever the x coordinate is at this point, right? Whatever the x coordinate is, actually, let me just put it, whatever the x coordinate is at this point would be the radius for that particular cross section. And then if I do it again, go out, I'm gonna rotate that and get a circular cross section. So we're going around the y-axis, so we'll get a circular cross section there. The radius of that circular cross section is again whatever the x coordinate is of that point. So my proposition is, if this equation is y equals, I'm gonna write 4 minus 2x, it's negative 2x plus 4, I think is the given thing, but 4 minus 2x, that's, if I know x, it'll tell me y. But in this case, what I really want to do is I want to be able to know what y is, figure out the radius, which is the x coordinate, and then rotate that. So what I'll do is I'm basically kind of actually finding the inverse of this, but it's not the way you typically talk about it. I'm going to subtract 4 and divide by negative 2 and say that x, let's say therefore, x is y minus 4 over negative 2. I'm actually going to write that. Y minus 4 over negative 2, right? So given a y value, I can now say that the radius is going to be that y value minus 4 divided by negative 2. That'll be the radius of the circular cross section. So I'm ready to do this. Let me do it, and I'll see if it's making sense to you. And if it is good, and if not, I will try to explain it more. How will I know if it's making sense to you? I'm going to try to listen to what I say and see if it makes enough sense to me. I don't know. All right. So you know what I could do? I could potentially, let me do this. Before I get into that, I'm going to draw a cross section. So this is going to be a cross section in like an xz plane. So like y equals a constant. So what do I do? Okay, circle. Like that. And then, all right, so this is going to be the plane y equals v, whatever v is. V, however, is somewhere between 0 and 4, right? Because look at our 3D thing in the bottom left corner. Y can go from 0 to 4. All right, so we're stuck in that plane. The radius of the circles, we said, so this is an XZ type plane. We said the radius of this circle, so this value right here is whatever the X coordinate is. But the X coordinate, we said, and I appreciate that this is a lot, the X coordinate we said is whatever Y is minus 4 over negative 2. So this point right here is at V minus 4 over negative 2, because that's what, so when Y is equal to V, X is equal to V minus 4 over negative 2, and then that's actually the radius of the circle that we get. All right, it's a lot. I appreciate that. So let's do this. Here's our equation. Here's the equation that I think we're gonna get. X will equal something, Y will equal something, Z will equal something. We're saying that Y is equal to V. So Y equals V. And then we have already said that V is between 0 and 4. Now, once we know what V is, we automatically know the radius of our circle. So I'm going to do X is the radius of our circle, cosine of t, and then Z is the radius of our circle, sine of t. So the radius of our circle is actually this part. That's the radius. So we're going to get, and it's crazy looking, V minus 4 over negative 2, and then cosine of t. And here I'm going to get V minus 4 over negative 2, and then sine of t. And then t is the usual thing, 0, t, 2 pi. All right, that's a ton. What I'm going to do is I'm going to take those to GeoGebra, and I'm going to graph it and show you that it worked. You should definitely also do this. This is the key. Like, if you try something out and then you go and you graph it, and if it works, it works. If it doesn't, you modify it, right? If you watched maybe the last video or 2 videos ago, or maybe 3 videos ago, it's been a long day, you saw me screw up, and I realized I screwed up because I graphed it. Here I go. So it's going to be surface, and the surface is going to be the quantity V minus 4 over negative 2 cosine of t, comma, V, comma, V minus 4 over negative 2 sine of t. All right, so V can go from 0 to 4, because that's what Y can do. And then T can go from 0 to 2 pi. Check that out. That is cool. All right, let's orient it so that we're looking at the XY plane. And you can see this edge right here is the line 4 minus 2x. How crazy is that? And then when we graphed our surface, it became the cone that we were looking for. So it did it. A fun thing that you can do with these, well, I think it's fun. I think a lot of things are fun that you can do with this. I'm going to make, what should I call it? I'm going to call it K, I guess. Let's say K is 0. And I'm going to let K go from 0 to 2 pi. I'm going to end this video at the end of this, if you're even still here. You want to go like 2 pi plus something. So I'm going to go 2 pi plus 0.2, I guess. It didn't change that, so let me just press enter. All right. Go up here, click that, and let's go from, instead of 0 to 2 pi, I'm going to go from 0 to K. And press enter. It disappeared, right? But move your slider. Ooh, how cool is that? You can see like parts of it. So if you only want like, if you only want the first quadrant part, we can make this pi over 2. I'm just going to do 3.14 over 2. And we get this. This is what I have been attempting to draw, right? Except this is like way better. But anyway, there you go. So we got it. I will be back to answer the next parts, but I think we're getting somewhere. So if you've been following along, make sure if you have questions, you're putting them in the shared document so that we can go over them at some point. I hope you are finding these helpful, because they're kind of a lot of work. All right, I'll see you in the next one.